Welcome to MathSearch. Now, this is the first video on triangles. What is a triangle? Now, a triangle is a polygon bounded by three straight lines. So, a triangle looks something like this. Okay? Now, the three straight lines which form a triangle are called the sides of that triangle. The sides of that triangle. Okay, so this is side number 1, side number 2 and side number 3. So it has three sides. Also it has three corners. Corner number 1, corner number 2, corner number 3. Now each corner is called a vertex of the triangle. So a triangle has three vertices. Okay, this is vertex number 1, vertex number 2, vertex number 3. A triangle has three vertices and three sides. And as you can see, a triangle has three angles. Hence, this polygon is called a triangle or a triangle. Traditionally, all triangles are divided into three categories based on the magnitude of their angles. Okay, so the first category of triangles are called scalene triangles. Scalene triangles. Now, in the case of scalene triangles, all the angles of the triangle are less than 90 degrees. All three are less than 90 degrees. Then we come to right triangles. Right triangles. Now in right triangles there is one angle which is 90 degrees. Now here all three angles are less than 90 degrees. Here one angle is equal to 90 degrees. That is why it's called a right triangle. Then we come to the third category, obtuse triangles. Now, obtuse triangles have one angle which is more than 90 degrees. Okay, so we have scalene triangles, right triangles and obtuse triangles. Now let us see what is the first theorem on triangles is. Okay, so this is going to be overall theorem number 4. Okay, theorem number 4. Already we have studied three theorems in plane geometry, so this is theorem number 4. So theorem number 4 says the sum of all the internal angles of a triangle is 180 degrees, right? The sum of all the internal angles, this represents angle. Okay, the sum of all the three internal angles of a triangle is 180 degrees. Now we are going to prove this statement. Let's see how we can achieve that. Now you can see triangle ABC. Now we are asked to prove the sum of angle ACB, angle CBA and angle BAC is 180 degrees, right? That's what we are asked to prove. Now to prove this you need a construction. So it doesn't matter whether ABC is a scalene triangle or a right triangle or an obtuse triangle. the construction is going to be the same. Now what is this construction? You are going to draw a line through any of these vertices of triangle ABC which is parallel to the side exactly opposite to that particular vertex. Okay, so you can draw a line through C parallel to AB, or through B parallel to AC, or through A parallel to BC. Okay, so we will draw a line, we will do our construction, we will construct this parallel line which we will call line DE, which is parallel to AB. Okay, now we have done that, right? Now here you can see as a result 3 angles are formed. Okay, 3 angles are formed. Now since DE is parallel to AB, now when you are asked to prove something like that, you have to say that I have done this construction. So we have constructed, right, DE going via C such that DE is parallel to AB. Okay, parallel to AB. Okay, you have to mention this. Now since DE is parallel to AB, you know that these two interior angles, they are equal, they must be equal according to theorem number 3. So angle DCA is going to be equal to angle BAC. Angle BAC. Similarly, angle BCE, this angle BCE is going to be equal to angle CBA. Okay, so DCA is equal to BAC. Similarly, BCE is going to be equal to CBA. Okay, CBA. Right, from theorem number 3. Okay, now we know that the sum of DCB and BCE is 180 degrees from theorem number 1. This angle and this angle, right? The sum of these two angles, they are adjacent angles, right? So the sum of this angle and this angle is 180 degrees. Okay, but we know that DCB is the sum of angle DCA and angle ACB, right? Therefore angle DCA plus angle ACB plus angle BCE is 180 degrees. The sum of this angle and this angle and this angle is 180 degrees. Now we know that the sum of DCA and BCE, sum of DCA and BCE is equal to the sum of BAC and CBA, because this is equal to this is equal to this, so the sum of these two is equal to these two, the sum of these two. Okay, right? So all you have to do is, because these two are equal, if we add ACB, angle ACB to both sides, right, this side must be equal to this side because we are adding the same magnitude. Okay, this part was equal to this part. Now we are adding the same magnitude to both sides, so this part has to be equal to this part. Now what is the sum of this part? 180 degrees. So 180 degrees must be the sum of BAC, CBA and ACB. BAC, this angle, CBA, this angle, and ACB. So the sum of these three angles are 180 degrees, which was to be proved, QED. Right? That is how we prove this theorem. It doesn't matter if this triangle ABC is a scalene triangle or a right triangle or an obtuse triangle. If you construct a line going through any of its vertices which is parallel to the side exactly opposite to that particular vertex, then you can come to this conclusion. Okay, so we have proven theorem number 4. What is theorem number 4? The sum of all the three angles of a triangle is 180 degrees. Theorem number 5. What is theorem number 5? If a side of a triangle is extended, the resulting external angle is equal to the sum of the two opposite internal angles. Okay, if a side of a triangle is extended, the resulting external angle, the magnitude of the external angle, is going to be equal to the sum of the magnitude of the two opposite internal angles. Let's see what this theorem is talking about. So you can see that we have extended side AB to some external point D. Okay, we have extended side AB to some external point D. Now as a result, you can see an external angle being formed. What the theorem says is the magnitude of angle CBD, let's call this CBD, is equal to the sum of the two internal angles which are opposite to this external angle. Now, is this angle the opposite angle of this? No, it's the adjacent angle. So, which are the two angles which are opposite to this angle? This angle and this angle. So, it says that the magnitude of this is equal to the sum of the magnitudes of CAB and ACB. Okay, so we are going to prove this. The proof is simple, right? Okay, now according to theorem number 4, the sum of the magnitudes of these three angles is 180 degrees. So let us assume the magnitude of this is alpha, this is beta, and this is gamma. and this is theta. Okay, now we know that alpha plus beta plus gamma is 180 degrees from theorem number 4. Now since beta and theta, they are adjacent angles, so beta plus theta is also 180 degrees, that is from theorem number 1. Okay, so alpha plus beta plus gamma is equal to beta plus theta. Now we will subtract beta from both sides. Okay, alpha plus gamma is equal to theta, Q E D. Okay, so we have proven theorem number 5. The magnitude of this angle is equal to the sum of magnitudes of these two angles. These two are the internal angles which are opposite to the external angle. That is what theorem number 5 says. We have proven that.